shoulder. It's going to translate to something really big down at the hand.
With small deviations causing big problems.
That arm's good.
Terry's lack of planning could leave our prototypes without a fighting chance. Coming up.
Something about this program I don't trust.
The robot prototypes start coming to life.
It's alive! Oh, that hurt.
And later, Terry suffers some sleepless nights.
It's 5 in the morning. I pulled an all-nighter. Oh, I'm officially completely ready for a nap.
Will he wake up enough to get our prototypes to the ring on time? At Prototype This, we're 1 week into our quest to prototype the future of gaming. A pair of giant boxing robots that interactively respond to a player's movements outside the ring. As the first week comes to a close, Mike arrives with Nemo, and they brought a very special delivery.
Ooh, they're gonna love them.
2 custom-built robot heads that Nemo built from nothing but junkyard parts.
Oh my God, that's beautiful.
Oh my God!
Yum.
That is great. For some reason, I'm thinking some kind of 50s car mashup.
Well, the robot heads that Nemo brought in looked really, really cool. I mean, to actually see them in like raw metal and all these different pieces welded together, it was like a work of art.
Mike and Nemo have nailed the raw industrial look that the guys were after. With each new addition, the robots get closer to becoming mean fighting machines. But before the robots can box, they first got to be built. And halfway through the project, still struggling with the first robot, Terry is anything but halfway done. The electrical engineers, however, are winning points. Joe's built a way to keep score in the game of the future. It takes a minute to show off his knockout scoring system.
So this thing is our prototype of the health-o-meter, which is the health meter for each robot. And basically we have the 9 spotlights that correspond to the robot's health. And during the match, as they get beat up, the levels will start decreasing. We'll go from green to yellow. We go to red. And as the robot's about to get knocked cold, lights go out, robot gets knocked out. Awesome. Good.
That's great for displaying the score, but if the robot won't register a punch, the scoring system will be useless.
The original plan was to use a bunch of momentary push-button switches mounted on the robot, so every time one robot's fist made contact with the other robot's button, we'd register that as a hit. But it occurs to me that there might be a problem given the force that these robots are going to put out. See what I mean? There's nothing left of the switch.
So Joe's opted for a method that doesn't require any actual contact to register a punch.
So we came up with the idea of using Hall effect sensors, which sense the strength of a magnetic field within its range. And the beauty of these is that we don't actually need to make physical contact with the sensor in order for us to now register a hit on the robot.
So Joe joins Mike in the workshop to put his idea to the test.
So what do we expect to happen here?
So right now,
Registers a punch.
If this registers a punch, our red spotlight should turn on.
They attach the magnetic Hall effect sensor and wire up the health-o-meter. Cue the oversized novelty boxing gloves, perfect for testing.
How hard can I hit this thing?
Go easy.
For this experiment, if a blow to the chin triggers a light, then these sensors are the way to go.
There we go.
High five. The sensor test that we just ran, attaching the sensor and magnet to the head, worked really well, I think. One concern is that we want to make sure the robots don't move around too much just as they're fighting to incorrectly register a punch.
Joe's knocked out the scoring system, but this project is only a few rounds in. Lots of work still remains, especially for Terry, whose lack of planning is starting to catch up with him. The boxing match is a week away, and he's only finished part of one torso. But Terry's never one to go down without a fight. He's added pneumatic cylinders to the skeleton that will control the robot's ability to bob and weave.
We'll do 2 in the front. If you pull both of them, you get a forward move. If you push one and pull one, you get a side move.
And with the hip bones connected to the backbone, the next step is adding the air hoses that will give the robots knockout power.
I mean, ultimately, when you put this whole thing together, the hoses are going to be like the blood veins that are pumping through this. They are supplying the power to the muscles. And I guess with that being said, this system right here would be the heart.
The heart is a switch box that fires the pneumatic cylinders and makes the robot move. But adding air hoses slows Terry's progress. So finally done with the design phase, he calls in the cavalry, Kevin and Diana, for help with the welding.
With any of these builds that we do, we bring in a specialty person. We're going to have to dive in full force on this now.
I've worked on the Golden Gate Bridge. I've worked on City Hall. I've worked on all of these huge city projects. So it's like no structural integrity. It's just for fun. So it'll be great.
The next day in the lair, Joe and Zaz are battling the final step in the control system. They've decided to use optical glyph tracking to read the boxer's movements. So all that's needed to make a complete control system is a way to track the boxing gloves in motion. And that's got the boys all geeked up.
So we know we can use optical glyph tracking to track the motion of the boxer's torso. But what we need to figure out now is how we can actually track the motion of the boxer's gloves. We can track the movement of the boxer's torso with a single camera pretty easily because the glyph is on a flat surface, which is the boxer's back. But what do we do about tracking these gloves? We can't use a single camera to track the boxing gloves because the gloves move too fast and they also get in each other's way. So we need to use a sensor that is fast and we can also sense in all different directions. Enter the accelerometer. Accelerometers are sensors that can track motion, such as acceleration or velocity.
Welcome to George Washington University.
There's a team at George Washington University that has put together a system using an array of accelerometers and some processing software to determine the hand motions of somebody using sign language and converting that into synthesized speech. Basically, we're doing a similar type of thing, using accelerometers in our boxing gloves to be able to track the punches of our boxers and control the robots.
When attached to a moving boxing glove, the wireless accelerometer makes a spike on the graph. Different types of punches are supposed to make different spikes. But even to Joe and Zaz's trained eyes, they're tough to interpret.
Right now, Zaz and I are experimenting with the wireless accelerometers and actually taking some data, and we're visually mapping what his punches look like on the screen and seeing if we can determine visually what types of punches that he's actually throwing.
So while Joe and Zaz take on the tedious task of differentiating a jab from an uppercut just by looking at a waveform on the monitor,